Hey guys, it's Jason. Welcome back. I've got the Pavo25 on the bench today. This is a 2.5-inch cinewhoop, which is just large enough to carry an ultralight action camera, but it's not as big as something like the Cinelog 35 from Gep RC, which would be a little bit harder to fly indoors in tight spaces and a little bit more intimidating around people. Now the build was pretty straightforward, although there are no detailed instructions included in the frame kit. You get a frame assembly diagram, but as far as putting it all together, there's no real instructions. And so there are a few pitfalls that you might fall into. So what I'm going to do in this video is I'm going to walk you through the build and setup of this quad and give you a few tips and a few things that I learned along the way that might help you avoid some of those pitfalls. And if you end up with the bind and fly version, it might be useful to see how this quad was put together, because you will have to fix it eventually. So if there's a specific part of this video that you're interested in, check out the timestamps in the video description below and you can skip ahead if you need to. I've been flying the Kopis 2.5 to get my indoor shots for quite a while, but when the Pavo25 came out, I really wanted to get my hands on one because it looked like it brought some really cool innovations to the table. The biggest selling point for me of the Pavo25 is the two-piece design of this frame. One piece is a carbon fiber plate where you bolt your motors and all your components to, and the other piece is this molded plastic duct section. But what that means is you can remove 6 screws, lift this carbon fiber plate out in order to get access to the components and work on your quad. With the Kopis 25, if you want to get to the stack, you really have to remove motors, remove the foam, remove the ducts. It's much more difficult and complicated to work on, which is typical of most cinewhoops. The Kopis 25 has also always had issues with jello, and it's real tough to balance the center of gravity since it has the DJI Vista in the back, with the battery mounted right in the center. And what that means is if you have no camera at all, it'll be back heavy. If you have a heavy camera, it'll be front heavy. And so it's tough to balance center of gravity with this design. The Pavo25 looks like it's improved on that design because it has the DJI Vista in the stack right in the center. You have your battery also right in the center, and this battery mount design allows you to move it back slightly or front slightly in order to compensate for the weight that you're putting, what sort of camera you're carrying and what sort of weight that entails. Another design difference is that the action camera mount is further back on the Pavo25. If we look at it there, the action camera mount is behind the front motors, and on the Kopis 25, the action camera mount is actually in front of the front motors, and that makes it, again, difficult to balance center of gravity. The Kopis 2.5 has a 20 by 20 stack, not an all-in-one board, with 35 amp ESCs, whereas the Pavo25 is using BetaFPV's all-in-one board with 20 amp ESCs. They're both running F4 flight controllers, and they're both running 1404 motors. In the case of the Kopis, they're 3800 kV, I believe. Yeah, 3800 kV. And in the case of the Pavo25, they're 4500 kVs. So a little bit of a higher kV on the BetaFPV motors, but that makes sense when you consider the Kopis comes with 5-bladed props and the BetaFPV comes with 3-bladed props. Now, if I hadn't just flown both of these quads, I would have said that the 5-bladed props would be quieter, but that's not really the case. The 3-bladed props on the Pavo25 are, if not quieter, they're lower pitch and less disruptive. So I actually find that the Pavo25 is quieter, or at very least less disruptive. The Kopis 2.5 makes more of a high-pitched whining noise when it flies. Here's what you get in the box: a diagram for assembling the frame, a bag with some battery straps, some adhesive for the foam protectors, and some 3D printed parts that you'll need to assemble the frame, a bag with some wires, an LED light, and a micro USB angle adapter for the flight controller, a bag with the hardware that you'll need to assemble the frame. The aluminum bracket they provide for the Vista is a really nice touch because it's a real slick solution for mounting the Vista with the 20 by 20 mounting holes. At the same time, it should provide some heat dissipation. The carbon fiber plate, there's no rough edges. It looks to be finished very well. One of the major features of this frame is that all of the components are bolted onto this carbon fiber plate, which is then installed into the plastic ducts using 6 screws. That should make the build much easier, and it should also make it much easier to work on this frame as opposed to some others which require a lot more disassembly, which can be pretty finicky with a small and tight build like this one. They include 2 sets of foam guards, which is pretty cool, so you can assemble it according to your style. You can be flashy red or stealth black. Finally, you've got the plastic duct section of the frame. It looks to be pretty durable. It has a little bit of flex, so it should be pretty crash resistant. I really like how the threads for the screws are already set into the plastic, so you don't have to fiddle around with lock-in nuts on such a small frame. I thought about recycling some components from a previous build to save money, but in the end I ended up going with the recommended components from BetaFPV, and the reason is that way I knew this all-in-one board would fit perfectly into this frame, and they've really designed it to be an easy assembly. Their all-in-one board has plugs for the receiver, for the DJI unit, even for the motors, which means it's a fairly easy build. The first step in the build process is to connect the motors to the flight controller. Now you have 2 options. They give you connectors, but you can also solder the motors directly to the flight controllers. I went with the connectors, and the reason being is that it would allow for easy motor changes in case I burn one, and it just makes the installation a little bit easier in such a tight build. Although I decided to use the connectors, I could see why some people would prefer to solder the motors directly to the flight controller. First, if you're using a different brand of motors, they might not have connectors. Second, the pads are actually larger, so you might end up with a more efficient connection. And the other reason is the pads for those connectors are actually tiny. So if you're not real comfortable soldering, you might actually have an easier time by clipping the connectors off and soldering directly to the flight controller, because those pads are actually much larger. If you go for the plugs, you can attach them to the top or the bottom of the all-in-one board. In my case, I attached them to the top because I didn't think they'd have enough space to clear the frame if I attached them on the bottom. The next thing I did was solder my battery lead to the all-in-one board. Now I noticed in the photos of the bind and fly version, they put the capacitor down at the board and you have a nice long battery lead coming out here. But the battery lead they give you with the all-in-one board is really short. So if you notice, most people who build up this frame, they have their battery lead coming out the side like this. I decided not to use the short battery lead that came with the all-in-one board, and I actually used a longer battery lead, but I did keep the capacitor at the battery lead, not at the all-in-one board, because space is so tight down there, I thought I would damage the capacitor whenever I went to remove the carbon plate from the frame. Then I installed the all-in-one board onto the carbon plate, and once it was held securely, I soldered up the LEDs and added a buzzer. Now a buzzer is not really necessary on such a small little quad, but I add these to all my builds. They're tiny, they're cheap, and they can really save your bacon if you crash in the bushes or tall grass or something like that, so I love buzzers. A few things to watch out for when you're mounting up your all-in-one board. They provide several sets of screws, but you're going to want to use the ones with the tiniest heads. I believe those are Phillips head screws, and the reason is the battery plate mounts directly over the hole where you're mounting your all-in-one board. If you use large screws, this battery plate will not fit over the screw head. Also, be careful to get the spacing of your stack correct. I used the rubber grommets and some of these nylon nuts because when I first installed the all-in-one board, I went to put my frame together, and the USB plug for the DJI unit was not accessible through that hole. And so I went back and installed these nylon nuts, and that made the spacing just perfect. As you install your components, it's definitely a good idea to test fit your frame, because your camera wire, your antennas, and any other wires you have around here, you need to keep a nice clean build, otherwise those wires will be pinched with the plastic here as it sandwiches together. The next step is going to be to solder up your Vista and the receiver. Since this board has plugs for the DJI harness and for a receiver, this process is really easy. And in my case, I actually pulled this Vista out of another build, and so it was literally plug and play. If your Vista is new, you might want to double check the wiring diagram just to make sure the wiring harness has been pinned correctly. And if you're using the DJI remote, you need to solder up all 6 wires, including the S-bus and ground on the end. In my case, I'm using Express All RS, so I clipped off the S-bus and ground wire. I went with the BetaFPV 2.4 gigahertz micro ELRS receiver. I also have a nano receiver from BetaFPV, but I decided not to use it in this build because even though this build is fairly limited on space, I appreciate the extra range that this antenna is going to give me, and the frame already has a 3D printed part to hold that antenna. When you're running the DJI system at 1200 milliwatts, it's really nice to know that you can fly pretty much to the end of your video reception and you're not going to fail safe. I mounted my receiver underneath the frame like this with a piece of double-sided tape. That means it's protected and out of the way, yet I have it sort of off-center, so the button and the LED for binding are both visible and accessible. I have a separate video planned for setting up ELRS receivers, but there are a few things specific to this build that I'd like to mention. First of all, this all-in-one board requires you to bridge 2 solder pads in order to use Crossfire. And since ELRS uses the Crossfire protocol, don't forget to do that before you get your quad assembled. Otherwise, the board won't recognize your receiver and you're going to have to take this all apart to bridge those solder pads. A nice feature of this board is you do have a plug right here for installing your receiver, and that way you don't have to solder onto those tiny pads on this all-in-one board. You also do have an extra UART, so you have a T1 and R1 pad if you, for some reason, don't want to use that plug and prefer to solder directly to the board. This is a good point to connect your flight controller to Betaflight and just make sure that your receiver is being recognized and that you can bind it okay. It would be really time consuming to have to take the quad apart later. So double check that it's being recognized. Make sure that your TX pad on the receiver is going to the RX pad on the flight controller and vice versa. Make sure that you've bridged those solder pads correctly, and it's a good quality control step before you go forward. This would also be a good time to activate your Vista unit if it's a new one, or just update it if it's an old one, because once you get the frame assembled, that Vista is sitting inside of this compartment here, and it's not going to breathe very well. And so it's going to be a lot more prone to overheating. So this is a good time to update your Vista as well. The next thing I did was to install my FPV camera into the TPU mount. I have the extra wires zip tied and a little bit of tape over it just so that when I install the frame, those wires don't get pinched. Good time to mention, this is a nano camera, a 14 millimeter camera. It will not fit a 19 millimeter camera. The last thing I did before my final assembly is just to double check that all the wires are tucked away and it's nice and clean, because otherwise they'll get pinched in between the frame and the carbon fiber plate. I installed my the antenna to my Vista. I had already shrink wrapped and installed the antenna to my RX. I fit those into the TPU parts and just made sure that the spacing for the antennas was correct. Nothing's going to get crunched. I test fit the LED lights, because when you put this together, it's a little finicky. Everything goes together perfectly fine, but you really need to take your time, have some patience. Otherwise, yeah, you can cut something you don't intend to. It's a little tough for me to do this on camera, but to show you how the frame fits together, you want to take this apart for this little lens for the LED lights, fit those together with the lights. This will then be inserted into this spot in the frame right here. Then you want to insert your TPU part over these standoffs. Everything should go together, and just be nice and patient. Take your time to make sure you're not cutting off any wires. I did have to install that LED lens off camera. It basically sandwiches together. You insert it into the frame. Then this 3D printed part goes over those standoffs. And if you're all good, then go ahead and insert these 6 screws and your quad is put together. The last thing to do is to use the included adhesive and install your foam guards. In my case, I used red because I think red and black just looks really cool together. As far as Betaflight setup goes, BetaFPV does share the CLI that they use for their bind and fly version, which provides a great starting point for setting up and tuning your quad. I'll put a link to it in the video description below, because that might save you some time. First of all, the accelerometer was not configured. It showed it as being upside down when it wasn't. And so I set the quad on a flat surface, calibrated the accelerometer, and it worked fine. Now the next thing that I did, and before I installed the props, was to check the motor direction in Betaflight. 3 of the motors were spinning in the correct direction, 1 of them was reversed, and so I went into Betaflight and reversed that motor, and at that point it was working fine. Now, if you're a little bit confused on motor direction and how you should have the props installed, since this is a pusher configuration with props out, I found an image from myfirstquadcopter.com that really simplifies things. So check out this image and that might give you an idea of how you should install your props. Then I double checked my UARTs. The only thing I had to change was for UART 3, I toggled on the serial RX for our ELRS receiver. And then I selected the option for a crossfire receiver since we're using ELRS, which uses the crossfire protocol. My receiver bound up to my transmitter without any issues, although I did have to change the channel map in order to fit what I have in my transmitter. And at that point, everything worked as expected. Then I checked my modes and switches in BetaFlight. BetaFPV's setup was basically the same thing that I use, with the exception of turtle mode. I think they had turtle mode on aux 3. I don't use turtle mode, so I deactivated that. And I have ARM set up as aux 1, I have flight mode set up as aux 2, and I have the beeper set up as aux 4, just because that's a comfortable position on my transmitter. A few other things that I changed in BetaFlight according to my own preferences. I changed the arming angle to 180, just in case I get caught in a tree and need to rearm to wiggle my way out. I changed the LEDs. They were set up to indicate your battery status, but since I don't really fly line of sight, I've always got my goggles on, I'll never see those anyway, and so I just changed them to a solid color, which I think looks pretty cool. Then I set up my OSD. What I do to set up the OSD is I just copy and paste my preferred OSD setup into the CLI, and that way, no matter which quad I'm flying, all the information in the OSD is where I expect it to be. All right, after flying this quad around for the last couple days, here's what I really like about it. First of all, the frame goes together really well. I really like the fact that I can pull that carbon fiber plate out to get access to the stack and whatever I have to do without having to take the motors off. That's really nice. I also really like the material they use for the frame. It has just a little bit of give, so if you run into anything, it doesn't feel like it's going to break. It feels real durable and it feels like it's going to last. Another thing I'm really liking about my Pavo25 is it feels a little bit more stable than the Kopis 2.5. That must be due to better center of gravity, or maybe it's the fact that the stance of the Pavo25 is just ever so slightly wider and longer, just a few millimeters over the Kopis 2.5. But for whatever reason, I'm not getting as much jello in the FPV feed or in the actual FPV camera. I also like the design of the foamies here. They're a little bit more reinforced where you're likely to make contact with an obstacle. And of course, the LED lights are a nice touch. They look really cool, and if you ever want to fly line of sight, it's really nice to know which end is back and which end is front. Without a doubt, the biggest advantage of the Pavo25 is the new design of this frame where you can just lift the carbon fiber with all the components right out of the plastic ducts, and it makes it so much easier to work on things. All right, you guys, that's going to about wrap it up for this project. I'm going to leave you with some flight footage, and if you have any questions or comments on this build, let me know in the comment section below. I'd love to hear from you. See you in the next one.